Today, on our special edition of Physics 101, we will be analyzing the physics behind the semi-truck flip from the movie The Dark Knight. In this billion-dollar blockbuster, The Dark Knight uses a cable to stop the Joker's getaway by flipping his escape vehicle. By searching online forums, I was able to determine that the average mass of a truck and unloaded trailer is about 16,000 kilograms. I was also able to determine that the velocity of this truck is 19.5 meters per second. Using these values, we can now calculate momentum. Momentum is a product of mass and velocity, and it represents the amount of motion that an object has. It is directly affected by both weight and diameter of the object. Therefore, as the weight and diameter of the object increases, so does the object's momentum or resistance to stop. Take these two cylinders for example. They're the exact same shape except one weighs 20 pounds whereas the other one weighs 8 pounds. Now if I were to exert a force on both of these cylinders, the one weighing 20 pounds would require more force to make it stop, since it has a greater momentum and therefore a greater resistance to stop. The formula for momentum is P is equal to m times v, where P is equal to momentum, m is mass, and v is velocity. By plugging these values in, I get 312,000 newtons per second as my value for momentum. Now by taking this value for momentum, squaring it, then dividing by 2 times the mass, I get a value of 3,042,000 joules for the amount of kinetic energy the truck possesses. Let's just say that the cable is able to withstand this total energy. The center of gravity for the truck is also assumed to be near the front top of the truck, making it easier to unbalance. The same way, with a person with a head 5 times the weight of their body will be unbalanced and easily fall over. We now have a lever where the front of the truck is the pivot point and the length of the truck would be the length of the arm. Now we need to calculate the upward force that's needed to flip the truck. To calculate the upward force, we first need to determine angular acceleration, which can be determined by dividing total radians by time squared. We can do this by first calculating the total number of degrees that our arm needs to travel. Our arm only needs to travel 91 degrees, since when it is past the 90 degree mark, gravity will pull it down to the other side. I convert 91 degrees to radians by multiplying by 0.0175 to get 1.593 radians. I next find that it takes 2 seconds for the object to flip over. Plugging these values into the equation, I get angular acceleration is equal to 0.398 radians per second squared. We now set angular acceleration equal to torque over moment inertia, where torque is equal to radius times the upward force required divided by moment inertia, which is mass times radius squared. Subbing in values and solving for the upward force that's required, we get a net value of 146,464 newtons up that must be applied at the back of the truck to flip this truck 180 degrees. Now this proves that this is possible as long as 1. The cable is able to withstand the immense momentum of this truck, and 2. The truck does not bend or break as a result of the force that is being applied on it.